resource pool. So when you have reusable resources, you have a big problem because the code that is also accessing those resources needs to have the final integers, which doesn't exist when you're compiling the library itself, because the final integer is only computed here when you input the application resources and the library resources, and then you get the final integers. So there are some complicated issues, and that's why basically when you have a library project here, you have library resources, code, and it's just injecting a lot of different areas, and it's making dependencies very complicated. And we didn't really support that at all in the old build system. Well, we support that, but not in a very nice way. So the current situation before Gradle, we would have a build system inside Eclipse, and then IntelliJ, JetBrains did their own support for Android, and so they added their own builder, which does about the same thing as our builder does, but there's something that it doesn't do because they're always kind of like a version behind, so that's kind of a problem. And then we have an end script that's customizable. So we have a pretty big end script that does a lot of things. And then we put that somewhere in our SDK, and then you have a simple script that just points to that. And there are some hooks to customize it, but not a whole lot. And a lot of developers just say, oh, whatever, I just take everything, I copy it into my script, and the reason it's in the SDK is that we want to be able to improve it so that whenever there's a new SDK, we just replace that one with a new version, and then you just point always to the right version. They just copy everything that's in there, and then just hack everything around, and it's a mess. And then we depend on custom and class tasks. So there's a discrepancy between your custom script and the new version of the task. And it's not supported by the IDE anyway, and you have something, it's a mess. So lack of flexibility is definitely one, and then a lot of missing features. So I just mentioned, more modularity and reusing code and resources. So that's a big requirement. And then our script or the builder inside Eclipse or inside IntelliJ would just generate just one application, and that's it, right? No ability to have different versions. No ability to have different version, like if you target a device that is running, so that's running an ARM chip, right? There are some devices running Linux or ARM, and so if you have some native code, like in a game, for example, you want to be able to have the ability to generate all those different native platforms, but you don't want to have necessarily a fat binary that contains all of them, so you want to have 3 different packaging. So that's something that we didn't support at all. If you had test had to be in a separate project because, well, we started from Eclipse, and Eclipse doesn't support 2 class paths, so we have different projects, and that doesn't really help a lot. And then better CI integration. It's like being able to have a single build system from, whether you're inside the IDE, whether you're on command line, or whether you're on continuous integration server. It's really something that we wanted because right now we couldn't do it. So Gradle. So I'm going to go through some of the features and how that works in Gradle, and I'll expand a bit more about how that integrates into some of the Gradle features or not in some cases. So first, before I move to that, I just wanted to also add that before we even decided that we wanted to switch to Gradle, we wrote a build spec about, hey, here's what it would, what would be really great about building an Android application if we had those concepts, if developer could create and define exactly what they want, and the build system would take everything. And then we talked with Hans and Adam, and we said, hey, we're trying to do that. Could Gradle actually schedule that? And they said, yes, of course. So here we are. So a simple Android project. So the first part, you're probably familiar with that now. It's about where to find our plugin. Hopefully, we can get rid of that soon, as soon as Gradle will figure out how to have a plugin repository. Then apply plugin Android, that's very simple. And then here, that's the beginning of our custom DSL, where we have 2 things that are required. If you're not completely familiar with Android, I don't know if you're aware that we have a lot of different versions of Android. And a lot of them are currently active. And so you have to choose which one you want to do. Like if you start a project with Java, like a basic, you apply plugin Java, you don't necessarily have to say, oh, I target JK5 or 6 or 7 or whatever. For Android, it's really required. I mean, you really have to think about it because it's going to impact which device we're going to target. So we wanted to make that required. So you have to say compile SDK version, and 17 is just like every new version, it's just an integer, we just increase it, API 17, then 18, then 19, then 20. 17 is the current one. And then build tool versions, I'll talk about that a little bit later. So that's a basic source set for a Java project, right? That's something that we didn't have before in Android. Before we only had source and resources because we had the test in another project. So we wanted to reuse that, but we have to do things a little bit different. And so, so on the left, that's the regular main source code. So we have a manifest that's where you have described a lot of what your application does or doesn't do, permissions and things like that. Then you have your Java source code, your resources, which are the regular Java resources, then OS, which is the Android resources. We only support resources for compatibility reasons, or if we pull them from a jar file, then they're supported, but really you should use the Android way. And then we used to put everything under source, but now we have source Java, and so we have AIDL, RS is for render script, it's GPU, compute stuff, and JNI. And then on the test side, we have about the same thing, except for the manifest because we generate it automatically. I'll explain why later. And also, we don't use tests, we use instrument tests because, so we have this instrumentation framework to run tests on a device, right? It's going to require a device to run because the API don't run on the regular JVM. And so we wanted to keep source test as, when we figure out a clean way of running unit tests only on your host, we want to keep source test to be more in line with what Gradle does. So instrument test, it's a bit long, but we may rename that at some point before we switch to one. So it's about writing tests that will run on the device. And one thing that, when I did the similar presentation to Android developer, just being able to tell them, hey, finally you can actually decide where the source sets are going to be, it was like a big thing because in the previous one it was source and res and we didn't have choice. So now you can change wherever you want those resources to be. So actually if you wanted to switch to an old format of having the Android manifest at the root level and then source and res, you would do that. The thing that's supported here for even non-Android users is that source sets here is inside the Android DLL object, right? And that's one of the differences that we have that Hans talked about just before lunch. I don't know if you were in this session. We can't quite reuse the Gradle source sets at the moment, but because they have a way of, it's like one source set gives one jar file, and the source set itself also has like an output notion, right? It's more than source, it's also, here's the output of the source set. Whenever you create a new source set, like if the main source set creates the main jar file, right? And you have a compile task for it. If you create a full source set, it's going to have a full compile task, and it's going to create a footer jar or something. I actually don't know the name. But it's very, one input, and we don't want that. I'll show why later. And that's going to break some issue, but I'm working with the Gradle way of people to actually fix that. The other thing is that, with just that particular project, you can build an application, you can build a test application, you can deploy all of them to devices, devices pure, right? If you have multiple devices, you can just push all the APKs. APK is the format of the Android application, it's the extension. So you can push all of them in parallel to multiple devices, run the test, gather the test result, and get the same XML and dashboard that the regular Java project gives you. Actually, the dashboard is a fork of the regular one because we had to deal with showing you the result for each different devices, which the regular Java project doesn't need to show you because you have a single environment to run on. All right, so on the task side, so that's the regular Java project, right? So we're doing things almost the same. On the assemble side, we wanted to keep assemble, check, build, and clean. And assemble will build, debug, and release. Now, Android has this thing where, for security reason, if you have a regular application, it's not debuggable. So we have a difference between a debug build and a release build, so that you can actually have the debug build be debuggable on your device. So we have to assemble both. And then check. Well, as I mentioned earlier, right? At some point we have checks that don't require a device. And we also have, we have something very similar to find bug called links. And we run that on check. And connected check and device check will be about running tests on devices. And I'll explain the difference between the two a little bit later. But then build and clean is the same thing. All right, so the big thing about the new build system is the customization, right? Being able to actually have developer figure out what they want to do. So we have a pretty extensive DSL, and I'll show you some part of it. So the most basic one is that default config object and it's going to configure some of the properties that you normally set up in your manifest. In your manifest, you would say, here's the version code and the version name. So the version code is really like, when Google Play Store see that you have version 12 on your device and it has 13 somewhere, it tells you that you have an update. Right, so the version code is what's important. Version name is just for display reason, it's not actually used. So you could put whatever there, put 2.0, but you could put, my application 2013. And then min SDK version is what version of Android you run on, and target is which version you're targeting for compatibility reason. So that's great. That's kind of pointless though, because if you can put that in your manifest, you can put that too. So what's the point? Well, that's why we want it, right? It's very basic Gradle stuff, but it's really something that we couldn't do at all. I mean, in Ant, it was just awful. You would have to basically write some script to go and insert that value in the manifest. Here, we just do that for you. You just set it up, you compute that, from, you can insert that through Jenkins with an environment variable or something like that, and basically have your nightly build just always increment the new version code, and then you're happy, hopefully. So I just talked about debug versus release. That's a concept that's very important for Android, right? As I mentioned, security reason, you don't want to have your release build that's on any device be debuggable, because otherwise I steal your device, I connect the debugger to it, I get your personal information. So the debug one explicitly say I'm debuggable. It used to be that it was a flag in the manifest, which is again kind of crappy because you really don't want to put that in your source file, right? So very early on we added this difference of debug versus release in Ant, but we're very, it was very rigid, right? We have ProGuard support, for example, to obfuscate your code. We would only run it in release mode. We would never really run it in debug mode, and that was a problem. So the notion of build type is one of the concepts that we introduced, saying I want to be able to have any number of build type. And we can control some flags. So we can control debuggable. We can control whether you want to run ProGuard or not. We can run signing configuration, right? The application that you're going to publish on your phone, it has a key that, it's really identify you as a developer of an application, so that if another developer tries to install the same application that you have, and it's identified by a package name, and you want to install the same application as an update of your own application, because so the security goal would be, I have an application, I have a lot of data, and that's secure because only the app has access to it. I install an update of it, and then I get access to all the data that was already there. So we have to make sure that the new update is the same as the previous one, and so the signing key is what gives us makes us sure that yes, it's coming from the same developer. So in a big company, you should be careful, and not every developer probably should be able to have access to the password to sign it. So you have a debug key that you can just sign, and then the tool also don't have to ask you the password every time you want to sign. Right? The debug key is created automatically for you. It has a non-password. It's Android. Very secure, and it's like we can automatically sign it with a fake key, basically. So we want to be able to, set that up, and I'll add an example a little bit later. And then, hey, why not also have some different behavior, either code or resources for one versus the other. And so by default, we give you a debug and a release, like you had in Ant or like you had in Eclipse. Actually, in Eclipse, that was another issue, that in Eclipse, when you work and when you use background compilation, that's always the debug version. If you want to run the release one, you had to export. But that means that you can't really debug the release. Not that it was debuggable anyway, but you couldn't actually deploy it even just to install it on a device on the ID because it was very rigid. So we wanted to fix that. We actually just released during I/O, so last month, the ability to have beta or alpha version through the Google Play Store. So hey, what if you want to have a custom build for that beta version? So through this DSL here, so build types, that's a typical Gradle container. You can create, so here we are configuring the debug version, and then here we're just adding a new one and configuring it the way we want. And that could be something, whatever you want it to be. So here, we're just setting some parameters, and we're starting to add, for the few Android developer here, package name, suffix, immutability. So as I said earlier, right, applications are uniquely identified by a package name that's defined in the manifest. And you can have two versions that have the same package name installed on your phone. That means that if you have your debug and your release, you can have them at the same time because they have the same package name. So here, very easy way, you just say, hey, for debug, I just want to add .debug at the end of my package name, and then you can install both at the same time. It looks silly, but do you remember that R class that contains all the integers for your resources? Well, it's generated in the package name declared in the manifest. That means that if you go and edit the manifest to add debug manually, suddenly the R class is generated in a different package. All your import in your code don't work anymore. And so there's some stuff to do manually. It's a pain, and so we do that for you. We don't actually change the import, that's the big deal. We just make it work. But so, it's a very nice way of just saying, hey, you want it to work, here it is, just one line, as opposed to go and hack that through some crazy file. So the other thing that you get from that is you get some extra source folder, right? So you have source main, you have source instrument test. You also get one for each build type. So source debug, source release, source beta, and if you create a new build type, you just get a new one. So the point here is, well, let's say in your beta version, you're going to give that to tester. You want maybe to gather some stats, right, from usage or crash report or whatever that you don't necessarily do on your release version. So you're going to want to have some custom code. So source/beta/java. You just put that in there, and it just appears magically in your final APK. Maybe some resources of where to send the data or whatever. Some resources. You're also going to want to have permissions, right? Android has very strict permissions about shown to the user at installation time. So if your application wants to contact to the internet to send those usage stats, you'll want to declare in your application saying, I require the internet permission. But if your main application doesn't have that, then you don't want it to be in your main manifest up here, because then every version of your application will ask the internet permission, and some paranoid users may say, oh, internet permission. So you just put it on your source manifest, Android manifest, source beta, Android manifest.xml, and we just merge all of that together for you, and we make it work. And of course, as I said earlier, with the assemble task, you also get an assemble beta. And so that means that when you actually call assemble, you make really multiple versions of your same application. So I mentioned signing configuration for the build type. With the release key and the debug key. So before we had zero configuration for that at all, but hey, since we have a very easy way of creating some DSL, let's just create one. So we have a signing config that's again just a regular typical Gradle container, and by default you have a debug object. And then here, so the debug key store is located in your home folder /.android/debug key store, so it's not shared. The problem is that every developer on your team signs with a different key. So if I have a version of mine and some team members say, hey, try my version because I added some stuff, you should check it out, I have to uninstall my version first before I can install that, because it's different key, so different developer, the uninstall actually doesn't work. So here, basically we're just saying, let's put the key store at the root of the project and check it in Git or whatever, and then just tell the debug configuration to use that key store. There's actually some other properties. There's the password key name, there's the store password, the key password, and the key name. But they're already pre-configured for the debug one. So here we're just basically saying that everyone can sign with the same one. So it's something that's very useful that a lot of developers wanted to be able to do, and we couldn't do that before in Eclipse. We could sort of do it in hand. So that's a great thing. Here's another example a little bit more complicated. So I mentioned that we can run program, and we can have some difference between debug and release, right? You could actually have some different code in your debug, maybe it's doing some extra logging or whatever, or maybe it's accessing a different server, right? You could have a debug version that accesses like a local server. You could have a staging server that accesses your staging version that accesses your staging server, and then you have something like that or whatever. And then you could have the release version, and sometimes you want to debug the release version. So here, through the DSL, we just say, okay, let's have a debug release type. And here, the part that I really like about the DSL is that, I'm just, we added that init with method on a build type. And so by just saying, first by accessing debug release, it's just going to create the debug release object of build type. And then it's just going to copy whatever within the release one. Right? So even though it looks very declarative, we're actually manipulating actual objects. Right? This is actually a build type, an instance of type build type. And then we set the debuggable to be true, package name suffix so that we can install it. We make it signed with the debug key so that anyone can build it. And then we just make the source set point to the other one so that if there was some custom files under source release, we just also use those files. And just from that, basically, you used to have just release that maybe was pro-guarded and obfuscated and there was some issue with that and you don't know what's going on. And boom, we just duplicate it, we create a version that's debuggable, but that's exactly the same one as opposed to being the debug that is not pro-guarded or whatever. And you can create as many as you want. Beta, staging, debug release, whatever. That's very, very flexible. And so, as I mentioned, that DSL, coming from Ant or whatever, what I find really good is that you're really manipulating a live model, right? You're not just setting a bunch of properties that are ready later. You're actually manipulating them. So here, everything that we have in the container is basically, you can use some custom logic to go and do something. So here, instead of having to go through each type, the debug one, the beta one, the release one, set the package name suffix, we just do it programmatically at the end, and that would just work, which is pretty good. I'll talk about that a little bit more when I talk about the IDE, but the other cool thing is that, that model, however it is that you configure it, whether inside each build type you set the property, or you do it programmatically, maybe here you actually want to test, hey, if the build type name is released, just don't do it so that you don't change the packaging, right? You could do something like that. What matters is that once the model is completely configured, this is almost, it's not actually the same model, but we build a new model from that, and that's what we send to the IDE. And the IDE will just know about that, right? So it gives us a very easy way of doing IDE integration, because we just define a model, developer configure it the way they want, and then we load that in the IDE. All right, so I want to talk a little bit about dependencies.
Before to go to dependencies, one question.
Yes.
How do you map the new concept of build types to the native build of the NDK? Because by default,
NDK support. So we're still designing how we're going to do that. So one thing that I didn't show really, I don't really have an example of my build types. Where are my build types? Oh, here. Technically, here there are some more properties. There is one of them is whether you want native development debugability. Basically, because when you say that you want to debug an NDK app, so NDK is native development kit, is C and C++ using the JNI. We'll copy GDB server inside your app, so that because there is control on the device and for security reasons that needs to run with the same UID as the app. So we copy GDB server. So whether you want that package or not is a flag. Where, the compilation option also will be there. Whether you want to compile with optimization or not. And also, like RenderScript has some options also on optimization, and in the future, hopefully, we'll be able to debug RenderScript code. So same thing will go there, whether you want to have RenderScript debuggable or not, and optimized compilation or not. So we'll have all of that here. It's actually already there. It's not used because we don't have NDK support yet, but it will be there. So the debug one will have everything basically, no native optimization, nothing, and then the release one will have full optimization for compilation, but you'll be able to change it and do anything in between.
But the idea is more to get to the part of, in case Gradle is going to release the support for C++, or why complete support for C++, your plan is to use Gradle for this, or to keep on with makefiles?
Well, we'll see what the C++ support is in Gradle. Ultimately, I'd like to switch to it, because I think it will be a better integration. The first integration will basically be, you have some makefile there, and then we just call the makefile. Right now, the makefile in the NDK have a lot of options. In the makefile, there's a lot of options about what ABI you want to support, ARM versus x86. It has some options, but where is the, it passed the manifest to figure out like the package name and things like that, and the minutes version. We've removed all of that. It's still there, but we've in a mode where we can input that instead of the command line of the script to build, and then Gradle will just figure out everything from the build variants that you have and send that to the NDK. So we'll have some control from Gradle about how the build is actually done. But as soon as the C and C++ support is done in Gradle, we'll see what we can do. I think it would be better if we can just reuse it on top of our toolchain, because in the NDK right now you have like 5 different toolchains, like 3 versions of GCC, 2 versions of Dependencies. So we'll have to figure out how that's going to work. But definitely we want to see what's going to happen. Yes?
Any timeline, like the NDK support will be?
Yeah, as soon as I can, like early July, I hope. End of June, early July. It's kind of a mid-June already, but it's next on my list.
So it's already in work?
The part on the NDK is done. We just need to do the wiring on the Gradle side.
The use of the standalone toolchain is still
Yeah. Okay. I'll come back later to more build variant stuff, but I want to introduce dependencies because that has some impact also. So, okay, so first some basic stuff. So configuration, so that's the basic configuration that you have in Java. And so we have almost the same ones. Mostly we rename runtime into APK because it's not really a runtime dependency. We package every dependency into the application because there's no dynamic linking or it's all static, so we wanted to rename it. A month ago it was called package until I discovered that package is a result keyword and you can actually use it with a Gradle file because it's a Groovy file, right? So APK. And then instrument test compile and APK, but then also you get the ones for all of your dependencies, right? So that's where, for example, if we go back to the beta, where you send some stat to the server based on your usage stats of your tester, maybe you want to use some REST API library or whatever to do the upload. So you could just set that up only on that one so that that library doesn't get packaged into your application, your regular application really. Dependency is very similar to regular Gradle. The only thing that you have to be careful about, and that's why I'm showing it here, is that it's only when we evaluate the data build type that we're going to create the configuration automatically. So you have to put the dependency scope after. It's not a problem, because anyway they're used only at runtime. But if you put it before, it will say, hey, beta compile, I don't know what that is. So you just have to put it after. So the big thing about dependencies, is those library projects that I mentioned when I had my big crazy graph of all those. I was going in all those directions. So we had some version before in Ant and in Eclipse of something that was kind of like supporting resources and code, but it was more like compile time than it was a mess. Anyway, so we have a version where a library project will create a bundle AR Android archive, and that will contain code and resources and other things, right? So we have code, we have resources, we just added assets that was not supported before in Ant or Eclipse. We have program rules as well, so that if your library, for example, want to say, in order for me to work, I don't want that class to be obfuscated, just put a rule that keep that, and then automatically that gets added to the list of rules. Like if your application depend on that library and say, hey, I want to use program, that library will say, oh, those rules also need to be used so that you don't do anything bad. And then we're planning on having, more toolchain and ID integration. So the first one definitely that we'll do is lint rules. So, lint, it's kind of like a find bugs, but for Android specifically for code and resources. And we want a library to be able to, from the library project, have like a source folder that automatically compile the rules if they're there, and package them inside the AAR. And then when you have an application that uses that library, those rules are automatically added to the list of rules to run whenever you run lint. And then, same thing for custom. So we'll definitely do that one. Another one that we may do, if you have custom views, custom graphical element, we have some API to add some interactivity on new elements inside the IDE when you have your WYSIWYG editor. And so we may have some ways of saying the library, here's how to improve the IDE experience by adding stuff there. It's something that's very different from jar files because jar files have a lot of problems for Android really. Jar files, even in Maven, if you upload a jar file somewhere in Maven, there's no easy way of saying this jar file, the minimum version of Android that it's going to support is version 7 or 8. I mean, it's not even possible for JDK. So for Android, that's not even possible. And so there's a lot of information inside an Android bundle that we have to have. On top of the code and resources, there's also a manifest that we have to put, and so we read the value from the manifest. So the runtime issue with Android really have to force us to create new format to really define the dependencies. You can still upload that to Maven Central, but then we're going to download that, and then during the build we'll make sure that it's really compatible or not. Yes.
Since you announced this at I/O, how many people have started to do these new formats? I mean, I did that day.
Not a whole lot, because I think there's some libraries that are slowly. Well, okay, so there's some issues. There's some libraries. They are using them or whatever, and so they have to switch. And the only way of using an IDE with Gradle is Studio, and Studio is kind of that early version, right? You have to complain to him. And then the other issue is that a lot of projects depend on some support library, some static library that we provide to provide backward compatibility on some new API on older version. And those who are not in Maven Central, and they're still not, but at least we have some sort of repository now, so they can start using them. But yeah, not yet. Not a whole lot yet, but they're slowly moving. I know the number one, the most used one, actually, Sherlock is slowly getting ready to be released as that bundle. But that's and also like the Maven plugin, which is done by a third party, has its own format, which is not that format there. Instead of having a single bundle with all the stuff inside it, they have the Java file plus another bundle that contains some other stuff. Which, yeah, I mean, it's just it's possible to make it work that way. I think it's better to have everything in one, because then you can support local dependencies, although we don't support them yet. But in the future, you should be able to get an AR file from somewhere, put it somewhere locally, and use that directly. Because Gradle supports local dependency, we want to support them. There are some limitations when you start supporting them, but you need to be able to support them. So we wanted a single file. Okay, so that's library project. Now the way you deal with the library project is exactly the same. The only thing that changes is the plugin name, but it's the same class path. So you can just put the build script. If you have a multi-project setup, just put it in the top, build up Gradle. You need only one, and then it's applied everywhere. So the DSL is a little bit different, and it's something probably that will have to change. And that's the nice thing about having two different plugins, right? Android versus Android library, dash library, instead of having just Android and some flag saying, hey, I'm a library or not a library, which is what we did before with Ant. We had a single script, Ant script that was huge, and there was just one property that said whether it's a library or not. Here we have different plugins because that allows us to deal more easily with different DSL. Because the DSL is created before you start evaluating it, of course, and so if you evaluate it through the way you say, hey, it's a library, so I need a new DSL, that just doesn't work. So here, we don't really have build types because, well, it's kind of weird to have, a library say, hey, I'm also a debug with data or something, And I think it's something that we'll have to add. So right now we only have two build types, which are the complete wrong names. It's like there's debug and release, and debug is actually the one that's used when you're testing, because inside your project you have your main code and your test code. To test, the output of a library is not an Android application, it's just a bundle, right? That's reused. So the test code, instead of uploading the main application and the main test application and have them test each other, we create a test application that embed the library, right? When it's basically the library output is just a dependency on the test application, so everything is self-contained. We upload just this one, and then we test this one. So debug is really the one that's used for test, and release is the one that's packaged and used by other modules in your multi-module project, or it's the one that gets published to an artifact repository. And debug signing is the signing configuration for the test application, which by default will be just a regular debug key store. So it's a little bit weird. There's a lot of developers who have started asking us, well, if I have a beta version, I want to be able to have all of my libraries, right? Have a multi-module project, there's one application and 5 libraries, actually more like 22. Like a lot of developers seem to have a lot of libraries, I don't know why. But like I have 22 modules and I want to have a beta version in all my 22 modules. And so right now it's kind of, first there's some dependency issue because I actually don't know how, in your project dependencies, I have to ask some relevant people how you say, hey, I have a dependency on another module, but I want, maybe if my module generates, publishes 2 artifacts, I want to choose which one I want to do. That's probably a way to do it, but I don't know yet. And then the other thing is, well, if I suddenly add a beta version in my main application, do I really have to go back to all my 22 submodules and create all of those things? So we'll have to see how we can make that work. Okay, so the library project originally were a way of helping developers create two versions of their application, right? You put, instead of putting all of your code into the library, into your application, you put it in the library, and then you have two application projects that reuse that library, and those are slightly different, they have different packages, and that works. Now, the reason you want to have different applications, typically it's like, okay, let's say you have a game, and you have paid versus free, and well, now you have also ARM versus x86 versus MIPS, and so it's actually a combination of paid versus x86 versus ARM, so you need to multiply, so suddenly you need 6 projects. Even though the ARM versus x86 versus MIPS is really just a packaging issue because the native compilation is going to generate 3 different libraries for each APIs, and you just want to select which one you package. And so we wanted to make that more flexible without having an explosion of different projects. So we created this notion of product flavors. So build types were about packaging. Product flavor is about different version of your application, like paid versus free, or multiple APK support, like and so there is ARM versus x86 versus MIPS, but you also have some GPU have different hardware texture compression for OpenGL, so you can also have different versions because like in your game, your assets are going to be pretty big. And so depending on the compression, you may want to have different APKs. So there's different ways of having different APKs. So the idea is to have 2 different dimensions. One is build type, one is product flavor, and you combine them to make a build variant. So build type, product flavor, and then build variant is the result. So you create them the same way you create the rest. Always you have a container called product flavors, and then you just create them inside. So here I'm creating 2 different versions. I'm doing something very weird. Also, basically I configured that one to be min-SDK 9 because you also have multiple APK version for different versions, right? So you have a version for old SDK for old devices, and then you want a newer version for newer devices that has new features. So you could create 2 different packages. But if you were really doing that, then the package name would be the same. But in that case, like 2 different package name. So if the package name was the same, you would just have 9, and you would generate 2 versions of the same app running on different versions of the devices. Or if you ignore the min-SDK version, you have 2 different versions that are completely different applications. And that will be installed side by side. So same thing for the source folder. We're starting to have quite a few, but then you have basically for each sort of product flavor that you create, you have a new source flavor one, and then you have a test one, right? Because when you're testing your code, the main code basically is tested with the regular source instrumentation Java. That's packaged into all of your test app. But because you have a different test app for different flavor, and then you have different code, right? So instrument flavor 1, we have test to code the features in flavor 1, and then implementation flavor 2 for flavor 2. Same thing for dependency. For example, paid versus free, you probably still want to be paid, so maybe in your free version you have some ads support, right? So you want to depend on some ad framework. So only in free compiled you would add a dependency on your ads framework. So as I just mentioned, a variant is always a build plus a flavor, unless there's no flavor, in which case it's just a build. So in that case, debug gives you debug and release gives you release. If you have flavor, then it's a combination. So earlier I talked about having like 3 different APKs for release, beta, and debug. If you have 2 flavors, suddenly you have 6, and we just generate all of those and make sure that compiles. So free versus paid is easy, but then you have that other dimension of, let's say, ARM versus x86 versus MIPS, and so you really have a dimension for build type, you have a dimension for paid versus free, and then you have another dimension for something else, and you could have another dimension, and you could have as many dimensions as you want. Although if you get to 50 APK, you might want to rethink what you're doing. So here we call that, unfortunately not dimension, maybe one day we'll just change that to dimension. So we call that flavor group, so it's really defining 2 different dimensions, and then when you create them, you just assign them to a particular dimension. This was easier than dynamically generating a new DSL based on what you wanted. So right now, that's how we do it. So, I mean, it's just an example, right? You would have 3 for those and 2 for those, and then the end result is, that. And I couldn't do a 3-dimensional thing, so I do a column here, paid with all the 3 APIs, and then free with all the 3 APIs. And same thing, for testing all of that, you have a version for each of those. I don't know if you saw Hans talk this morning. where you show that, and the end result is that, when you look at the list of tasks that we actually generate for that, we showed an example that had like 300 different tasks. We just automatically generate everything that's needed to build all of that, and that's a lot of tasks. So how do we combine all of those different elements, right? You have some configuration specific for variant, for build type, you have some configuration specific for flavor, and then maybe for another dimension of flavor. So how do we combine that? So first, the source code. So that's, I kind of mentioned that earlier when I was saying that the regular Java source sets have this notion of, if you have source/main, you have a compile, it's called compile task, it generates a jar file. If you create a new source set and you call it foo, you have source/foo, and then you automatically get a foo compile that creates a new jar file. This is not what we want, right? And that's kind of encoded in the source set, like the regular source set has the notion of output, which in our case doesn't really mean anything. I'm working with Adam to fix that. But as you can see here, the source main is combined with two other flavor folder, which could not exist, that's fine. And then the debug one. And then we create the output for that particular variant, which would be free mix debug. Now, when I'm going to compile the release version, I'm going to have main, free, mix, release. So I'm going to reuse basically the main one or the debug one for multiple variants, right? So the same source folder is reused multiple times depending on which combination you're using. So that's one of the reasons we couldn't use the source set. And what that also gives you is, if you want to have a debug and a release version that does things slightly differently, you could have the same class in source debug Java and source release Java, right? You have two versions of the same class. As long as they provide the same API, if a class in source main Java, import that class and use it, as long as they provide the same API, you're safe. We just pick the right one based on choosing which source folder to use. Yes?
The order of precedence?
No.
If which one wins?
That's what I'm saying. There is no. It's not like you can have a class here and then a class here, and flavor should override this one. You can't have the same class in main, but you can have the same class in source free and in source paid because it's the same dimension. And right now it's very that works at compilation time. In the future, we want also, on the IDE side of understanding that and making refactoring aware of that, so that if you have a class in source paid and in source free, and you rename it or you rename a method in it or whatever, we should also impact not only what uses it in the current variant, but also other versions of it, so that refactoring is aware of those duplicated classes. It's something that we want to work on. So that's source folder. So it's multiple source folder, one output. It's basically we just tell the compile class, here's 4 source folders, just compile them all together. So duplicate class will generate an error. Resource and assets is slightly different. So in Android, we have, under Res we have a lot of resource, and it's very structured the way that works. The idea here is that, your main resource, define resources like strings, layouts, bitmaps, whatever. And then your bitmap can redefine a particular version, and basically it's an overlay, and it's going to replace whatever is already there. If you have something in debug that is not in main, then it will also become available. But if you have something in main and in debug, debug will win. So that one is higher priority. And here you have 2 flavors, and so basically when you define your flavor groups, the order is actually important. I don't remember which the order is, it's documented somewhere. All right, so for the signing configuration, better should have been one line, but apparently Google Docs, when you go full screen, just does a different layout. So the idea here is you have 2 ways of signing, right? You can either put your signing configuration in the build type, or you can put it in your flavor. The advantage of putting it in your build type, so for example, debug, right? The debug key is in Android build type debug. And that way every debug version gets signed with the same, every flavor, every variant that is a debug gets signed with the same debug key. If you have, let's say you have free versus paid, you probably want them to sign them with the same key. So you would put your release signing information in a release. because then every release gets signed with the same one. However, if your two different applications are not free versus paid, but they're, let's say Google versus Nook versus Amazon, maybe you have some signing requirements on each of those stores, and so you want them to be signed separately. And in that case, you don't, you would have Android product flavor, and then you would have here like Google, Amazon, Nook, or whatever. And so you would not put the signing on the build type, you would put it directly on each flavor. So by doing that, you can figure out what is important for you, different signing config for release or a single one. And then finally, the package name, right? The package name is the thing that's really important because it uniquely identifies your application. So the version that's in the manifest is the base, and it's always the source, right? And then if you define a new one, like I did here, package name, then we're going to use that package name. But if we don't, if we don't set one in here, in those flavor, then we use that one. And then we choose one here, and then we add potentially a suffix based on whether you had one or not. But the thing that's important is that when we generate those classes, like the R class that's always in the package, we always generate it in the package that's found in the manifest. That way your code doesn't change. Your code is the same no matter what the package name at the end is. And, that's really important for Android. If you're an Android developer, you would understand. All right, so the thing that's super important here is that, I mentioned that, Hans showed an example of like 300 different tasks. As a developer using the plugin, really what we want you to do is just use the model and say, hey, use the model to describe what you want. And then once you have that, the plugin is going to generate tasks and, generate, different tracks. You have the release versus the debug or whatever, and generate a certain number of applications. It's very different from what we had in Ant, where it was just one basically imperative, file. But it's also very, so it's great for us because then that model, as I said earlier, we can take it and put it to the IDE, and the IDE knows exactly what you meant. So that in the IDE, when you say, hey, I want to work on my free debug version, and you say launch, we know which file that was generated actually, because the model that we sent to the IDE is, here's the number of real variants that we have, and here's the output file for each of those variants so that we know which file to actually launch. Or we know all the source folders, and we can do proper indexing of all the Java and the resources based on where you are, right? That's super important for us to modelize that and to send that to the IDE. The downside is that we have to make sure the model is as extensive as possible and we're not missing anything. But the key point here is that in Java, you can, in the regular Java plugin for Gradle, you can very easily add a Java task or add any sort of task, because it's very limited, right? The Java plugin really does. There's a compile class, there's a compile task, there's a process resource task, then a class task that use those two, and then Java. It's basically 4 tasks. It's very easy, right? In our case, very easily you're going to generate 3, 4, 5, 6 applications, and you don't want to go and start inserting stuff. You can if you want to, but we really want you to just create the model and create the task. We do allow you to manipulate that after. So once you've created your module, we create variants. And so, you can access the variant, and then in the variant, you get access to, you get access to things like that. A unique name that you can reuse. Like if you want to create new tasks for each of those variants, you might want to include a unique name inside each of those tasks, right? Because let's say you had a task food, but you have 6 build variants. You want 6 versions of your task food, so you want to use that name to be able to generate that. And if you need to generate some output files or whatever, we'll give you a folder. It's not actually a full name, it's just a relative folder, so that you could do build/full/ that folder to put your so that it does no impact, there's no conflict between all the different versions. Then we have the output file, we have the build type, the product flavors. Then you have the merge flavor, which is a mix of that, like basically the way we resolve all of those values. all the build tasks, so all of those dots that I have in my very first graph, all of those are tasks, and they all show up there. And then whether it's a test or a tested version. So if it's an application, which version is testing me, or if I'm a test, what am I testing? How do I get installed? If it's a test variant, what are the test tasks? So you have access to all of that through the API. The only thing that's kind of right. So and you have actually that sorted in 3 different collections. The Android plugin just outputs those 2 application and test, and the library plugin outputs the library and the test. The thing that's weird is those 2 big things, right? Is that because I'm kind of stupid. Here, we use each because we just say, hey, it's a collection. Let's get access to the collection, and basically when you do each, you loop on all of them, and you. But to do that, they need to be created, because what happens is that we pass the model, and then at some point we have to create the task, and we can't really create them as we evaluate the model. So we create all the tasks after. And by doing that, which normally is done at the end of the whole evaluation of your project, there's an after evaluate hook in Gradle. So we just go there so that at the end of the evaluation of all the DSL, our listener is called and we create the task. Doing that will force creating the task. Turns out that this magic Gradle collection where we can do .all instead, and that allow you to change the current item in the collection and the future item in the collection, and we should use that instead so that we can just create a closure that will be applied when the tasks are created. So we need to change that so that we can remove those 2 bullet points. Because right now it's a problem, right? Right now, as soon as you call application variant, if you go after and you say, hey, here's a new build type, that's too late. So we won't change that. Okay, so the other thing is, we have all those tasks here, so you're going to be able to go and say, hey, for my debug version, I want to look at the process resource task and maybe change something. Well, there's some issues because we have some of those inputs are not just like, here's 2 folders and you could add a 3rd one, for instance. Some of the inputs are actually like graphs and things, and so that's a little bit complicated. And so, so we kind of limit what you have access to, but you definitely have access to the intermediary files. So you may not have access to the main inputs that are provided by the model, and if you want to change that, use the model. But all the intermediary files you could. So for example, between compilation and the bytecode conversion, if you didn't want to use ProGuard, you wanted to use some different bytecode manipulation, you could just easily insert yourself saying, hey, what's the output of the jar? Input that into my new task, and then output something and give that output to the new to the task that does the bytecode conversion into OVM format. So you could definitely do that. But yeah, it's going to be difficult if you want to really change some of the main inputs that you have, like the basic source folders or resource folders, and to change them. If the model doesn't expose something that you want, then it's somewhere where our plugin has a limitation, and really the solution would be for us to fix the model and to provide more flexibility. All right, testing. So I talked a little bit about testing here and there. So to do a quick recap, we have some source sets, source, instrument test, and maybe some drop flavor. We have some configuration, right? Instrumentation test compile, whatever. We generate the manifest. So just to give you, you probably don't care too much about the detail, but basically the manifest, also has its own package name declaring, because that generates an Android application, right? That's going to test another Android application, and so in the manifest of that one, there's a unique package name, and then the package name of the application that it's testing. But we saw that the model can configure in all sorts of ways the package name, so we just generate that automatically. It's something that the old build system forced you to create manually, because that was easy. Now that we can have 6 different applications that have 6 different package names, we want to manage that ourselves. Right now, we only test one build type, which I think is a big limitation that we need to fix. So if you have source, debug, release, beta, debug, release, beta, debug, release, we actually for test only target one of those, and we'll probably have to change that. And I've already embedded the test applicator, I mentioned that already. So we have some DSL to configure that as well. Here to change which version we're testing just one, but at least you can change it. So we have a bunch of DSL where you can go and change the test package name. If you don't do that, we automatically generate one. We take the tested package name and we just add the test at the end. The test runner, which is similar to the Java test runner, but the Android one, by default there's one, but if you're creating your new one, you can also create it. And then Free Flavor could do that, also overriding whatever is in the default config. It's pretty basic. Okay, so testing scenarios, that's the part that's really interesting, I think. So Gradle has check, and if you call check, you're basically expecting that you're going to run all your checks, whether that's your JUnit tests, whether that's your find bugs or code style or whatever. Of course, you can create like integration tests with Gradle, and that's relatively easy to do, and that's great. In our case, we have a much bigger problem is that you need one of those to actually run your test. So there's really like 3 different scenarios in our case. There's the I don't have devices, I still want to test something. So I mentioned earlier that we wanted at some point to be able to I mentioned that we wanted to be able to run like local JUnit tests anyway. So there's some third-party library that are doing something. We'll probably integrate that. So in the future when you do check, we'll run those as well. And then we'll run links, we'll run find bugs, although right now it's not compatible. I'll talk about that. So that's check. The second scenario is I actually have devices, right? I'm a developer. I'm at my workstation. I have like a phone and a tablet connected. I want to deploy my app to my devices, and I want to just run tests on them and just get the results. And here, that's what connected check will do, right? It will look for connected devices, and then in parallel just push all the APKs that it has. And so if you call connected check, it's actually going to do it for all your variants. So if you have pair versus free, it will test both of them. And just deploy that, run the test there, and get back, XML file for the JUnit result, and some HTML dashboard that shows you that. And that works great, except that you probably don't expect your continuous integration server to have those connected, right? Because it's like they're always going at some point to disconnect. You have to unplug them, replug them, or whatever. And then, I don't think your IT would like to have some devices that have to deal with that. And if you use, Jenkins agent and you have 10 Jenkins agents, well, do you have device connected to all of those? It's just, it doesn't play, right? So we have to find another situation, another solution. And so device check will run, there's 2 different scenarios of running that on a CI server. So the first one is you have your testing server somewhere, and then likely you have probably a device lab. If you're a big company, you probably have your own device lab. You have somewhere a bunch of devices. You have a computer that allows you to connect to them, have a queue, and then you upload an APK to it, and then it waits until the devices are available, because you can't run UI tests on parallel on devices, right? So you have to do one set of tests, then wait until it's done to do the next one. So you probably do that. If you're a smaller company, or if you just don't care about maintaining that yourself, there's other companies that do that for you. So we created an API called the test server API. It's very basic, very simple. There's one interface to implement, and then basically, if you have a plugin that does that, basically you can super easily deploy all your tests to like some cloud third party. So there's 2 services that are doing the integration, AppThwack and TestDroid. TestDroid actually published their Gradle plugin that support that API like today. And Zachary here, if you have some question about it, it's an awesome project, and you should go and talk to him because he works for TestDroid. And it's really good. You can just, they have like hundreds of devices in the cloud. You have and so from your server, really, from your build server, you can super easily take the result of your build and go and send it to them to actually have it tested. The other scenario is, if you have emulator already, you can have emulator in the cloud and have them be on demand. And I think in the future also we'll have the ability of starting and launching emulator directly on your server to do the test and then quit them. But so we have another API called device provider and device connector. So the same thing, you get the list of devices here, and instead of uploading the APK and getting some remote dashboard later, the API is much more interactive. We get a list of devices, and then we, for each device, we say connect, and hopefully something happens somewhere. Then we upload the APK, we run the test, and we are really a live connection. We get the result as the tests are running, and then we close the device, and then we have the local result. And there's a company called Manimo. They run emulators in the cloud, and they have also a plugin, and it's been published also, it's available on Central. I'm not actually going to do a full demo of that, but just to show you, so I have a good script here. So on the ClassPass, I have those two plugins, Manual and TestDroid. You have to use for TestDroid 1.0.1 unless you're using JDK 7. But that one is compatible with 1.5, so use that one. Then you just apply them, right? You do apply Android and then you do apply Manual and TestDroid. So what those plugins do is, as soon as they're applied, they check first that the Android plugin is applied, and if it's applied, they're just going to say, hey, here's my implementation of the API. And that's all it's doing, right? They do provide also, some of their DSL, right? So Manual, for example, you can give them a list of devices. If you don't give them a list of devices, they'll just give you access to 50 different emulator configuration. TestDroid here, you can set username and things like that. We still have to, see exactly how the DSL will be. In the future, you'll probably be able to choose devices or things like that. But just by doing that, and really, they actually don't do any work at all, because they don't. Having those plugins try to figure out how. Okay, and they could, right? They could query the model to say how many build variants, what happens. And get the output of those files, but that's not really what you want. The plugin, our plugin, is in charge of running tests. So when you call connected check, so actually here, if I do tests, so here you see that there's two tasks that were created, right? Manual instrument test and TestDroid upload. The name is because they implement the two different APIs. And the device check actually, all the way here, depend on those two. So when you call device check, it will say, hey, I have those two implementation of the API, just use them. And and we just use the API and we call them. So if you have 6 different builds or 6 different variants that needs tested, we'll just upload all 6 of them, or we'll test all 6 of them in parallel. We just take care of all of that. And so you could have multiple services. If you're a big company and you have your own device farm, on the server, you probably have a server that maintains all of those devices. You could easily just make a custom implementation that go and connect to your farm so that your CI doesn't have to care with build. You don't have. One of the issues is that if you don't do that, and there's some solution right now where Jenkins is configured to take the output of the build and do something with it and send it or test it or whatever, right? There's an emulator plugin, for example, for Jenkins. For Android, right? An Android emulator plugin that will take the output of a Jenkins build and run that on the emulator. Then that means that because Jenkins doesn't know about the model, it doesn't know about all our build variants. Every time you change the Gradle file to add a new variant, you also have to change the Jenkins configuration to go and tell it, hey, there's a new version, so you should also go and get that output, right? Before it was fine because our build was so rigid that there was no way you could configure it anyway. But now that we have all of that configuration, everything should, belong inside the IDE, right? Inside the Gradle. Gradle knows everything about your build. It should drive how your tests are running, and it should drive, all of your continuous integration. So it's really cool. You should definitely check it out if you want to do some testing on Android. All right, let's talk about the IDE a little bit. So, if you look at current IDE integration in Gradle, you have really 2 modes, right? Gradle has an IDE plugin and an Eclipse plugin. If you use those plugins, what they're going to do is they're going to look at your project, all your modules, and all of that, and create, IDE files. And it's great. And I use that, when I develop my plugin, I apply the IDE plugin. And whenever I change my dependencies, because I have a lot of them that are changing, so I rerun the plugin to reset up my dependencies on my new repository, and then it works. And you can, that will work. The other way is to have the IDE actually be able to read a Gradle project or a Gradle file, right? And so there's a plugin for Eclipse that does that. Done by Spring, I think. And then IntelliJ has one. NetBeans has one as well. What they do though is that they just look at your dependencies and then they're like, hey, okay, here's your source set, here's your dependencies, so I'm going to set up the ClassPass, and the IDE is going to do the build. And it's fine if it's a Java project. In our case, as you can see, it's a little bit more complicated, and we don't want that, right? We really want to have, the idea is just not do anything about build or project setup. We just want build.gradle to be the source of truth and also to do the building, And that's what we wanted to do, right? So that's what I mean by 100% external project, right? It's like you shouldn't be able to go inside the IDE, once you load the Gradle project, going into IntelliJ, into module structure and go, hey, let's add a library there. If you do that right now, what it's going to do is that inside the IDE, you'll have that new library, but then you exit the IDE, you try to build it with Gradle, and it just doesn't work because it doesn't have that setting, right? Having a UI in the IDE, it's fine, but what it should do is it should edit build.gradle, and then it should be really important. And so that's what we're trying to do with the IDE. So before I give you a demo, so since Gradle 1.6, Gradle were added the ability of a plugin to expose a model through the tooling API. Because before, there was only two different models. There was the Eclipse model and the IDE model that were really tailored for those two IDE. So that when you use the tooling API to say, hey, give me a model, you really got one of those two. And we don't really care about whether it's Eclipse or IntelliJ. We just want a single Android model. And we'll have different support for that in those two IDE, because anyway, we have so much Android-specific support to do in each IDE that it's much more important for us. So based on the model that you configure using the DSL, we have a model that's really only what we need for the IDE. And we're adding more features to it, but like all the build variants are there, the output file is there, all the source folders are there so that we know exactly what you're using and all of that. And we just load everything. We create project inside the IDE for that. And the big part is here, right? We don't care about the IntelliJ builder. We call Gradle every time you call make, which is fine in IntelliJ because we don't call, build all the time in the background. In Eclipse, where you basically compile and save, that's a bit more complicated. And also it works because there's no indexing issue, right? IntelliJ just does its own indexing by parsing all the source code. It doesn't rely on the output of the compiler, so it's fine. Eclipse looks at the output of the compiler, so that's a problem. And of course, there's going to be some performance issue at some point because it's just not as lightweight. There's like out-of-process communication, so we have to do some improvement there. But so far, it just works, right? When we compile using Gradle. So we have more work to do. As I said earlier, the current UI will just edit the IDE model, but we don't care about that. So we want to disable the UI and have new UI that's very similar, but actually edit build.gradle and then re-import. And code assist for build.gradle is super important as well. So, all right, so what I have here, okay, let's see. So this is a project that I imported from Gradle, right? So the build.gradle is the one here on the right. The one at the top, I think, is just the base one. That's empty. Yeah. So that's my module, right? I say, here it is. It's basically the very basic one. There's nothing interesting in it. But remember, I said we already have two build types, right? So here we have a new window that's specific for Android, where we show right now I have only one module. I have two versions, and so here. If you look at the source code, I don't know if you're familiar with IntelliJ, but the blue one is your main source code, and the green one is your test. So right now we have main, Java, that's the source code. We have debug, because we have the debug build variant that's selected. And then we have a single Java project. I have a bunch of other folders that are not used just yet. So I'm going to add a project flavor. So I'm going to go here and say project. Save. Normally there's a auto import that detects file change and do the import, but it doesn't quite work yet. So there's a sync project with Gradle, so we're just going to do that. It's going to basically query the Gradle tooling API, get the new model. And right now it's just doing something. So right now the implementation, they go through out of process to do that support and then to do the tooling API access, and then the tooling API goes out of process, so there's two serialization, and also it's not super optimized right now. But all right, so what happened? Well, what happened is that if you look at the left here, suddenly my build variant is flavor 2 release, and am I not running the right one? I just did that and it worked.
It worked.
Yes, it works just before the new one. That's because the version that's public right now doesn't. If you look, okay, it actually doesn't do anything. It's very strange. Yeah, there's a bug in there, obviously, in the public version. We're releasing a new version today that should fix the issue, and I don't know why. Maybe I'm running the wrong one because I didn't override it. Normally, what should happen is that it's a very strong bug, right? It shows the stuff, but then the pop-up doesn't contain the right value. But normally, it should work. At least the version that we're releasing today will have that fixed. Alright, so if it doesn't work, just restart it. Set Windows. Loading. Alright, so we have those 4 here. So here, right now, it's flavor 1 debug. And so if you look at the source folder, I do have debug as a source folder. I do have flavor 1. I do have, I should make that bigger. I do have instrumentation test flavor also as one. And then if I change to flavor 2 debug, what's going to happen is this one will become a source folder, that one will disappear because it's flavor 2, and then those two will change as well, right? And there we go, it just happened. So, we have that support, and also when you build, we check what the current variant is, and part of the model that we send to the IDE is what is the name of the task to build that particular variant, so that we only build that one. We'll have to add another option to say build all or something. We'll have to add more features into the IDE to make them really understand the concept of variants. When you do launch over there, up top to launch, it really launched the current variant. And there's a lot of other Android-specific features that, like when you do WYSIWYG editor and you have the main resource into main res, and then you have maybe something in debug res, and you have some custom things there. We already support that, so that when you're showing a particular UI in debug or in flavor 1 versus flavor 2, if there's some difference due to some resource overlay, we properly show which one you were actually using. But the big key part here is that, as you can see, we understand what's going on here in the IDE, and based on the section here, we can really drive what's going on when you launch, what's going on when you want to build. The next step, as I mentioned earlier, is like having the refactoring actually understand that concept so that we can refactor stuff. Because the point is that right now, like that folder, for instance, IntelliJ doesn't care about that one, right? It's not a source folder. So if you do refactoring and you have some class in there that should be impacted, it's just not going to happen. So we have to add those features. But the basics are there, where the IDE, if you ignore the UI, naturally, there's a big warning when you try to get that, It's just before you get to the regular UI that allow you to, change that, where you really shouldn't change that in that UI. Because if you change that, that's just going to change the ID file, and we don't want you to change that. We want you to change the build. So we need to remove all of that and to replace it with a UI that edits build.gradle. But it's getting there. So that's for IntelliJ. We are, we're going to work with. We already started very recently contacting the people who do the plugin, the Gradle plugin for Eclipse, to give us also the kind of hooks, because as I said, the custom model is only from 1.6. So the current Gradle plugins, they just say, hey, I'm Eclipse, just give me the Eclipse model, and that's it, right? So we need to have some hooks for us to be able to intercept the current mechanism to say, hey, don't ask for the Eclipse plugin model, ask for the Android model, if it's an Android project that you're employing. And then NetBeans, who also has a third-party Gradle plugin, also has someone working on Android support, and they already have support for that, where they actually query for the right model and then configure the Android support in NetBeans to actually use the model coming from Gradle. So it's pretty cool. And that's just what I said. Did I miss something? Yeah. Okay, build environment. It's not really interesting if you're not a developer, but basically we had a lot of issues before where, like a big issue with our Eclipse plugin is that in the same plugin you had some fancy editors specific for Android, and then you had an Android builder. And so when we did a new release that had fancier editors and different build system, because we added some features and maybe like broke some things in order to make things better, but broke something, then developer couldn't update to the new one, and we didn't really offer for download all the previous versions, so they were kind of stuck on the new one, and that was a good problem. So here the ID is not responsible for build, right? It's external build system, that's really important. The plugin version, developers are in control, you choose which plugin you're using. It's in Maven Central, you can use whichever you want. We're not going to remove all one when you publish the new one. And the build tools here, so the build system, the Gradle build system still calls some external tools that are part of the Android SDK. And same thing, the SDK used to only have one version of those tools. And in order for us to be more flexible in how those tools communicate, if we want to deprecate some option in those tools or add new ones that are incompatible, now the SDK has the ability to have any version of those. So in your tools, in your build.Gradle, basically you'll be able to say which version of those build tools you want. The Gradle plugin may force you to use a certain range, depending on compatibility, but you'll be able to choose and only to upgrade to those whenever you feel like it. Because we release a new version of the build tools. Right now it's 17, it matches the API 17. Whenever 18 is released, we'll release a new version of those just because it comes from that branch. It may or may not improve things, but it may or may not add features that you care about, but it may enable features for when you target API 18, so you do want to have a new version of it. But it's up to you to figure out whether you want to switch to version 18 or not. If when we release plugin version 0.5, maybe 0.5 will say, well, I require at least 18. In that case, you have to change, but it's up to you, right? You're already deciding, you're making the choice of switching the plugin, switching to that, it's up to you, and you can test whether it's working. If it doesn't work for you for whatever reason, if there's a regression, switch back to the old one. We can still keep the newer IDE that we released at the same time. I just want to finish with some things about the really integration with Gradle itself. I mean, our goal is to be like 100% compatible with all of the Gradle ecosystem. It's just not the case right now. Like the source set is a big issue. The CI integration also, when you suddenly have devices like you have flavors, so you're testing for different flavors and you're testing for different devices. We show that in our dashboard. So when you do a Gradle check normally on a Java project, you get an HTML report. Our HTML report is different. It's actually a fork. We took the code from Gradle and we just forked it to add the ability to show purpling different devices and things like that. And we have to do that because we have more results. We'd like to not have to do that, especially on CI server. I mean, ultimately we'll probably have to do some sort of Jenkins plugin, but the fewer we have to do of those, the better. So we're working with the Gradleware company to try to improve things inside Gradle to expose some of our concepts, or at least so that we make them compatible with our concept, so that we can just plug into their stuff instead of forking some of their parts. I don't want to fork the source set, right? We're just doing it because we have to. But that's our goal. So I mean, I'm mentioning that because on our mailing list, a lot of people are like, well, I want to use Scala, and you have different source sets, so I can't. It's a big problem. Yes, it is. We want to fix that. That's why Scala is on there. And that's the thing. Oh yeah, the other thing is, as I mentioned, right, we delay the tasks after the project is evaluated, which is fine, but there's some other plugin that kind of want to modify the tasks. And so when they want to modify it when they're applied or something, and it's just not available. And so they would have to also delay their task manipulation to after ours is done. And if they don't do it right now, they're just not compatible, and they would have to be changed to do it. So we need to find a way. But some work is in progress to do anyway, delay task creation. And quick mention on the roadmap. Our main goal right now is polish, because there's a lot of really usage issues that we found when we started publishing it and talking about it. GenAI support is coming soon. lint will come after, and then after, I think a lot of the work will be around like CI. We really want to have a really good story there, and we need to improve it, and there's a lot of work to do there. I think that is it. All right, questions?
Yeah, on your IDE integration, do you
Yes.
see the features of IDEs using Gradle as the root source, the way you are doing it, as a Android plugin specific IDE integration, or a Gradle eventually being available for any build using Gradle, not with all the flavors and everything
Yeah.
that's specific to Android?
It's going to depend on the requirement of, I mean, if you're fine with your IDE doing your grid because you have a very basic Java project, you're fine. If you have a lot of custom stuff, maybe you want to have Gradle delegate to it. It seems.
Now, I'm in that camp where
Yeah,
I
mean,
I have to go and have my Gradle configuration configuring the IDE, and then I have to go hack the XML files from the Gradle build script.
I mean, I think it totally makes sense to have for, at least as an option for every developer, the ability to, if they use some build system, whether it's Maven or Gradle or whatever, all the IDEs should be able to have external build system. It just doesn't make sense without it. The work that we are doing, we're working with JetBrains to have extensions in IntelliJ to be able to do that. So it's not like we're using private APIs. So anyone could go and have a proper Gradle project that's not Android, that just does the same thing for a regular Java project. And we'll do the same thing for Eclipse. We're going to work with the people who did the Gradle plugin for Eclipse to simply add extension to it. So we won't use private APIs or whatever. So anyone can go and do it.
This slide, do you Gradle wasn't have?
Yeah, sorry about that because I always finish my slide at the last minute. So I uploaded them actually this morning to the site, Gradle Summit, so they will be available there. Yes?
Do you need to change the code of IntelliJ to implement those features, or this is a plugin in IntelliJ?
So IntelliJ has Gradle support already, and we're working with them for them to add extension to it. Right now, they're working on version 13 right now, and they're just doing tons of changes around Gradle support anyway. And so they're just adding those features that we need in 13. So when 13 comes out, because our version of Studio is based on the master branch of 13, so when 13 comes out, all of those will be available in the standard IntelliJ. But if you want to actually use that, and if you want to have a custom plugin that exposes its custom model and have the IDE support it, you have to do a plugin in IntelliJ to understand your custom model. But the hooks to do that will be there.
So it means that JetBrains will maintain this studio?
No, they will maintain the Gradle part, but the part that, our plugin basically plugs into their Gradle support to be able to read out and understand our model and set up all of that. So we do a lot of the work, but we depend on some of their stuff. They're just opening hooks for us. Any other questions? Yes.
Mr. Miner, currently, it's the Android main tool that generates the basic build of XML which is done. But it's going to be the same with the build of
Yeah. We'll have that to support it, to create a basic build of Gradle.
Okay. One problem that we were having before, that switching between one SDK and the other, sometimes we end up in having build of XML that were incompatible with the previous version, and because of the came up with some stuff generating and compiling. With Gradle, is this going to improve, or there is
Well, you shouldn't have any problem because we don't rely on anything in the SDK anymore. Right? I mean, before the build of XML was inside the SDK, so if you get a new version that will break because we give you a new version when you update the tools, then you have a problem. But it's not the case anymore because we don't read anything from the SDK anymore. That's the good environment stuff where like you're in control. Now you can actually have an SDK where you install as many things as you want or not. The things that we rely on are all available in different versions, and you can choose which one you target. And the stuff like tools, the tools component inside the SDK, but there's only one of them. We don't lose anything from it. So you're fine with that. All right. Thank you.